Let's see what happens with a higher order derivative. We're going to find f. Our function is f triple prime is equal to the square root of t plus 2 times the cosine of t. Let's talk about trig functions. The derivative with respect to x of the sine of x is equal to the cosine of x. Therefore, the antiderivative of the cosine of x is equal to the sine of x. The derivative with respect to x of the cosine of x is equal to the negative sine of x. Therefore, the antiderivative of the sine function is the negative cosine of x. We'll just do one more. Since the derivative with respect to x of the tangent of x is equal to the secant of x, the secant squared of x, the antiderivative of the secant squared of x is equal to the tangent of x, and they would all have a plus c. Now let's turn our attention to this third derivative here and remind ourselves that the square root of t is actually t to the 1/2 power. It's important because I'm going to be using the power rule for antidifferentiation. I'm starting with f triple prime, so I'm going to write down f double prime. For t, add 1 to the exponent. I have t to the 3/2. Divide by the new exponent, so that gets a coefficient of 2/3. Minus 2, just as a constant doesn't change a derivative, a constant doesn't change an antiderivative. The antiderivative of the cosine function is the sine function. So, sine of t plus a constant. Now we've only gotten to f double prime, so we're going to continue on. F prime of t is equal to, now again for t I'm going to add 1 to the exponent, so I have t to the 5/2, and then divide by the new exponent. My coefficient was already 2/3. Dividing by the new coefficient, I'm now going to multiply by 2/5. Remember we said that the antiderivative of the sine is the negative cosine, or since I already have a negative in front of my sine function here, the antiderivative of the negative sine is a positive cosine. So this is going to be plus 2 times the cosine of t. Now, this c was a constant. If this was a 3 or something, I'd have to write c times t, right? Because the derivative of c times t is c. So we got to think about going the other way, anti-differentiating. I pick up a constant. But now I'm going to move this over. Now I need a new constant here because I've done this another iteration, right? So plus, I'd like to say c because, hey, it's c for constant, but that implies that this number is the same as this number, and I can't be implying that. So I'm going to turn this into a c2 and the original is into a c1. And now we're just keeping track of this stuff. You could say c and d, I don't really care. Final step, well, I'll have to clean up the coefficient here, but f of t is equal to, I already had 4/15 as a coefficient here, right? Now add 1 to the exponent, so I get t to the 7/2, divide by the new exponent, so I'm going to multiply by 2/7. And then the antiderivative of the cosine function is the sine function, so plus 2 times the sine of t, plus, now this is going to get a little bit weird. c1/2 t squared plus c2t, now I need some more room here, plus c3. Look, c1 is a constant, so c1/2 is also a constant, and so I'm going to end up replacing c1. I don't like that color. I'm going to end up replacing c1/2. Our final answer is going to be f of t is equal to 8 over, I think that's 105, t to the 7/2 plus 2 times the sine of t plus, Now I've already used C2, C3, and C1, so unfortunately this is going to be a C4. It doesn't follow in order, but that's okay. T squared plus C2t plus C3, and we can check this by differentiating a few times.